Here's a relation defined by a set of ordered pairs. This relation associates 99 to A, 87 to B, 65 to D, 92 to A, and 53 to F. We're going to identify the domain and range of this relation and write it using a table of values and as an arrow diagram. Go ahead and pause the video and try to determine the domain and range of this relation. The domain of a relation defined as a set of ordered pairs consists of all the first coordinates, or you may think of them as the x coordinates of the ordered pairs. So in this example, the domain consists of the first coordinates 99, 87, 65, 92, and 53. The range of a relation, written as a set of ordered pairs, consists of all of the second coordinates, or you may think of them as the y coordinates of the ordered pairs in the relation. So in this case, the range consists of the second coordinates A, B, D, and F. Remember, there's no need to write the range element A twice, even though it appears in two correspondences of the relation. And it doesn't matter which order you write the domain and range elements in. You could write your range as F, B, A, D, and it means the same thing. Now go ahead and pause the video and try to write this relation using a table of values. In previous examples, I've written my table of values vertically, in which there are two columns, one for the domain and one for the range, and each row becomes a correspondence. However, this one I'm going to write horizontally instead, where my table will consist of two rows, and the columns will give the correspondences. But you can write it either way. So to write our horizontal table of values, our domain elements will go on the top and our range elements will go on the bottom, and each column will come from one of the ordered pairs in our ordered pair definition, because those give the correspondences of the relation. So we have the pair 99A, which associates 99 to A. So we'll have a column with 99 in the top and A in the bottom. Our ordered pair 87B associates 87 to B. So we'll have a column with 87 over B. We have a pair 65D that associates 65 to D. So we'll put a column with the domain element 65 on the top and the range element D on the bottom. The ordered pair 92A gives us another column, and the ordered pair 53F translates to our fifth and final column. So here is the relation defined here, written as a horizontal table of values. Now go ahead and pause the video briefly and try to write this relation using an arrow diagram. To write our relation as an arrow diagram, we write all of our domain elements together on the left and all of our range elements together on the right. Note that it doesn't matter which order the domain elements are written in and which order the range elements are written in. Now that we have our domain elements and our range elements, we draw an arrow for each ordered pair from the first coordinate or domain element to the second coordinate or range element. So the pair 99A associating 99 to A gives us an arrow from 99 to A. The ordered pair 87B associating 87 to B gives us an arrow from 87 to B. The ordered pair 65D associates 65 to D, and we get an arrow from 65 to D in our arrow diagram. The pair 92A associates 92 to A, so we get an arrow from 92 to A. And our final pair in our set of ordered pairs associates 53 to F. So that gives us an arrow from 53 to F in our arrow diagram. And this is how you write the relation defined here as a set of ordered pairs using an arrow diagram instead. Again, since it doesn't matter which order you write your domain and range elements in, yours may look slightly different.